So I have a polynomial here that I like to factor. And this one is a little different from the previous ones we've looked at in that it has some actual numbers out there for the coefficients other than just the usual implied 1. So I'm going to do this in 2 steps. First, I'm going to handle the coefficients. Then I'm going to handle the variables. As you get more practice at this, it'll kind of start to become more natural. It's like I say, yeah, okay, I'm going to take out a 2x, and you can just go from there. But for now, I'm going to work out the steps, and I'm going to do each of those 2 parts separately. So let's start with how we're going to handle the numbers. I'm going to look at the 3 coefficients, 4, 12, and 2, and I'm going to say, okay, the greatest common factor of 4, 12, and 2, the biggest number that goes into both of them, all 3 of them, is 2. So now I'm going to kind of go back to the original method we talked about, and I'm going to rewrite each of those coefficients as a multiple of 2. So this will be 2 times 2x cubed plus 2 times 6x squared plus 2 times, and I'm actually going to write it out here, 2 times 1x. So you can see there really is a number there that's left when I take away the 2. All right, now I'm going to say, look, all of these terms have a 2 in common. Let's bring that out in front. I'm left with 2x cubed on the first term plus 6x squared on the second term plus an x on the last term. You know what? I'm going to leave that 1 in there. Right? I'm going to leave that 1 there because I'm going to need it to make a point when we start taking about looking at these x's. Okay, so that takes care of the coefficients. Now I'm going to factor the variable parts. So I'm looking at these, and I see that all 3 terms have an x in them. And the smallest exponent on those x's is a 1. It's that term at the end. So I'm going to take a single x away from all 3 of these terms. So this 2 is going to stay out here in front. I'm going to take away that x. And let's see what's left. On the first term, there's 3 x's. I'm going to take away 1, so that'll leave 2. So there's going to be an x squared, and we still have that 2 out in front. Plus, now on the middle term, I've got 2 x's. I'm going to take 1 away, so that's going to leave me with a single x. This term will be 6x. Plus, now look at what happens here. There's only 1 x there. I'm going to take it away. What's left behind? Now, do you see why I explicitly wrote that 1 out in front? I really wanted you to see that there is something there that's going to be left behind. And there's my factor form. Right, so the rule I always tell my students is when you're factoring out the greatest common factor, if your original polynomial has 3 terms, there's going to be 3 terms left inside the parentheses. Right, the number of terms is always going to stay the same. You're just going to have that stuff that you factored out in front of it. Okay, so if you want to see the full context, the first link below will take you to the lecture where I go through this process and we actually do it using the distributive property, similarly to how I handled the coefficients here. The next link takes you to the last of our factoring examples, where we're talking about how to handle a negative sign, right? Which is not hard. Really, we're going to be following the same process, right? But negative signs tend to throw people, so I think it's a good idea to look at an example. And of course, if you like this presentation, please don't forget to click on the like button down below as well.